Hello, and welcome to Apogee's and Forrester's webinar on layering mobile APIs for profit and business agility. So today, Randy Hefner from Forrester and myself will be talking about mobile APIs, some of the implications of them, the architectural considerations, and technology trends. This presentation will be posted on YouTube along with our past webinars and videos for you to watch later at your leisure. Also, please check out our community site where you can learn more about Apogee and API technologies. So with all that out of the way, I'm going to turn things over to Randy. So let's get things started.
Hey, thanks. Appreciate it. So there's a lot of API talk out there these days, and there's a whole lot of it that is religious. There's a whole lot of it as well that's kind of amorphous and unstructured and sort of amounts to cheerleading for APIs. And I want to add in my remarks today a bit of clarity around why and how to design and deliver APIs that can actually make a difference. It can drive your business forward, and that really more importantly for the long term can provide a base for business agility, because it's one thing to know what you want to do tomorrow to deliver some greater profitability or benefit or business efficiency or whatever. But the thing is, you've got to do more than just deliver benefits for tomorrow. You need to enable an ongoing stream of innovation. And the interesting thing about APIs is that they can do both. But if you're not careful about how you're thinking about them, then you may do a little bit of the profit thing today, but a lack of business agility will just sort of grind you into a hole over time. So that's what we want to talk about and drill into today, and particularly to bring it home in the context of mobile APIs and the need for different kinds of APIs in a mobile context and how that relates to this broader question of business agility. So just in case anybody's wondering, APIs are mainstream. There's a lot of conversation out there about the big players like a Facebook or a Google or a Twitter or whomever is a big social player or somebody that's got an API. But there's a lot of APIs out there just for regular run-of-the-mill enterprises. Chicago Transit Authority, Stock Exchange in Turkey, E-Trade. You got an E-Trade account, you can basically do your own program trading if you want. You got APIs that are for credit cards and prescription refills and universities, and one that I like to highlight on here is Con-way Transportation, because their external interfaces for integrating for freight transport and logistics, those have actually been out there for more than a decade, and not as APIs in today's parlance and common conversation, but they've been out there and available to improve business efficiency for Con-way and for Con-way's customers. So important stuff out there, and it's not just about the big players. It's about mainstream enterprises, government enterprises, nonprofits, commercial organizations. It's for everybody. So, but there's a particular industry cry out there to these days, which is that mobile needs APIs, and indeed mobile environments are a major driver of many enterprises getting into an API space, and that has to do with the fact that mobile environments tend to have limited programming frameworks that don't necessarily work well with older styles of services that have been out there for a while, like SOAP. But here we touch on a point of religion in that many talk about SOAP as though it's old, dead, gone, yesterday's business. It's not really true. There's many people expanding their use of SOAP as there are expanding their use of REST, and so both are important in the world to come. But there is a bit more attention to REST, and mobile is one reason, because REST APIs do work better with mobile because of the limited frameworks and programming environments that require a different sort of programming. But the thing about it is, though, there's not a lot of nuance around this industry cry for mobile and APIs. When you try to ask questions and get guidance in terms of, well, okay, what kind of APIs? How do we do APIs for mobile? You sort of get an exclamation point pointing at the APIs and say, well, APIs. Well, yeah, but what kind of APIs? APIs. And there's not a lot of nuance there. Well, I think more is needed here if you really want to understand how to do mobile APIs and how to simultaneously be pursuing this broader objectives of business agility. Well, first off, mobile's not the only channel that we're working with. And so APIs can be useful for web and kiosks and other kinds of channels, set-top boxes, B2B integration, a lot of different channels for interaction. And each one of these channels works differently. Yeah, you can do something with responsive web design so that a web app will work on PC and on a mobile device, and things in between, tablets and whatnot. But the thing is, different channels work differently. They're better at different things. There are certain tasks that you'll do in one channel or do deeply in one channel where you may only do a little bit of financial analysis on a mobile device. On a PC, you maybe do heavier financial analysis. So they work differently. Airline check-in works differently when it's at a counter or a mobile or a kiosk or a web. So that channels work differently. And so you have multiple channels that you need to enable. Tesco, a retailer in the UK, they've got kiosks in store that work differently than their mobile website, that work differently from their PC-based, laptop-based websites. So, but if you don't have this sort of understanding that there's something more needed for how you design APIs, then you can basically create a recipe for a good bit of API-based business chaos. And here's where we'll touch on another bit of religion, which is around REST APIs in particular, which is that they must be resource-oriented. It should be, identify your resource, your entity, and just do create, reads, updates, deletes against that data. And that allows you to do all kinds of things with the APIs. But it's all about resources. Well, okay, let's play with that a little bit and say we've got a mobile app that we need to deliver, and we've got underlying applications with ERP data and customer relationship data and the like, and we want to do some kind of product display and ordering. Well, if all we have is data-oriented APIs in the API layer, what that does is pushes the business logic up to the mobile app layer. Well, certainly you want some logic in the mobile UI, and on the mobile device. That's part of what's good about it is you've got some CPU power there, and you can do some interesting things, as you can do in a web browser as well. But okay, that's great. You get this going, but now you say, well, oh wait a minute, we want to do a kiosk as well. Well, so you push the business logic up to the kiosk. Now the thing is, we're going to get around later to distinguish between different kinds of business logic. But the thing is, here what we've done is duplicate how we do orders and the like across different channels, and thereby created a good opportunity for inconsistent business operations, inconsistent results, different ways of handling things. So this is going to create a bit of chaos. So let's try to think, and move toward how do we stem the tide of this kind of chaos. Well, the first thing we have to understand, again, if we're going to bring in this theme of business agility, is that customer experience is not the only thing we're doing. We got a bunch of other technology-oriented things that we're trying to do, whether it's virtualization in cloud and big data with MapReduce and zero trust security environments to deepen security down into the core of our solutions, and social and business process management. lots of different technology stuff that we have going on. If you look at it from a strategic point of view, then let's not get caught up in the technology. Let's understand what it is we're trying to achieve as a business. And this should be a more important driver of how we think about architecture, how we do architecture. After all, we're not trying to achieve technical agility for its own sake. We want agility at a technical level so they can deliver business agility. And what are the kinds of ways that business changes and that we need to do different things at a business level? So we think about and understand a number of business things that need to happen. Well, what this kind of leads to when you take this better business focal point is the vision that we're trying to achieve. The goal really is an agile, digital, customer-centric business, where we're nimble while being secure and engaging customers through many different channels and many different possibilities. And coming up with new channels and constantly adapting the channels that we have and getting smarter and smarter, bringing more data into the mix to help us guide how we serve customers, what kind of products and product features we do, what kind of data is even available through our APIs. So we want to have a much broader, more flexible business vision. And across this vision, then, be able to deliver consistent business outcomes, consistent business improvements, consistent customer service, consistent order fulfillment, consistent data and analysis across all different contexts where we come to market, whether it's internally and the internal employees that drive the business from the inside, whether it's web, kiosk, mobile apps that we engage with customers and employees through, whether we expose our capabilities through industry marketplaces where we don't necessarily even control the user experience, and any kind of value chain integration. And the one I like to throw in at the far right here, which is just a big placeholder for who knows what in the world's going to happen tomorrow, is digital disruption. Who would have thought, that you could get at a company with very small numbers of employees and, spin it up and 3, 4, 5 years later get bought for $1 billion or $4 billion or whatever the latest crazy headlines are about what Facebook is paying for one thing or another. Well, that's because it's very easy to start new ideas, and through APIs, you want your organization to be dragged along in somebody else's runaway success. That's what digital disruption's about. It's a whole other conversation as well. But these kinds of thoughts lead to a bigger architecture picture for which APIs are just the foundation. It's a bigger picture of the future of solution architecture that Forrester describes and talks about as digital business design. And APIs are a key foundation for this kind of future. They're not the only thing you need. Lots of other different angles into designing a business for flexibility and agility, and integrating all the different silos of technologies from our historical vintage applications to new SaaS applications, and throwing business process management and event processing and a number of other things into the mix. But APIs are a key foundation to making the whole thing work. So let's talk then a bit about how to come back to that mobile scenario and deliver a better kind of portfolio of APIs to that mobile app that meets the immediate goals of delivering what the mobile app needs and making the mobile app work in a way that is tuned to the way that mobile apps work. I almost says native to the mobile environment, but I don't want to imply that you're doing native mobile apps versus mobile web apps. Terminology clash here. It happens in the technology world. But something that is tuned to how a mobile device should work while delivering this bigger issue of business flexibility. I wanted to use a B2B context just to bring in another one of the challenges that we have to describe this. So let's say you got a B2B scenario and you come to market with technical APIs that provide application integration into your ERP and your CRM applications. And these are technically oriented to do the things that these applications do. Okay, great. What have you just done in terms of your business partner's view when they connect to you? Your business partner will be then looking in terms of, well, I've got a logistics application, or I've got this application, or whatever application, and I'm going to do application-to-application integration based on these technical building blocks that are delivering me, particular ERP data items or CRM data items and integration capabilities and the like. What we're doing is creating technical coupling between our B2B partner, a customer, a supplier, a government entity, whomever it is, and our application base. This is a recipe for business inflexibility. In that you want to change your applications, you're now impacting the APIs that your partners are integrating with you, even if you didn't change anything at all about the business relationship. Bad idea. Let's not do that. Let's instead, it is after all a B2B relationship. Let's design it based on the business relationship. So instead, let's create business building blocks, and in this case, an order fulfillment API that has the business transactions, the business queries, the business level things that we as a partner are promising that we'll let our B2B partner do. So now they are more concerned about how their logistics process works, and that how they can now integrate their process with our business based on the business relationship. The order fulfillment API in this case now insulates business partners from our applications, and more importantly, it provides the business view of how to conduct our business relationship. By the way, in the travel industry, back in the days when SOA was making a change in the industry, and SOA, by the way, is still very important. That's another bit of religion that sort of implied in, that I'm trying to debunk as an implied theme of part of my remarks here. But in any case, airlines, hotels got great value from SOA. Well, why? They had been doing external integration for at least a couple of decades before SOA came along. The thing is, it changed their external integration point from these technical building blocks to business building blocks like make reservation, retrieve flight options, book hotel room. These were the ways that business API now looks in the travel industry versus the old technical X.25 based interfaces and the like. Okay, so what does this have to do with the mobile environment? Well, let's bring up our mobile UI now, and now let's look at having our core business applications with these business building block APIs built on top of them. And now what we're doing is, rather than exposing particular applications, it's the business thing that needs to be done that a business person would understand if you described it to them. Well, some of what needs to be done from that mobile UI is basically direct invocation of a transaction that's supported within our business building block APIs. Maybe we submit an order, and that order actually has to happen and flow. Work of processing and fulfilling that order has to flow across multiple business applications, but we expose that through a single transaction-oriented API for submit order. But there's going to be other things that are happening in that mobile UI that what we really want to have is a user interface API. What do I mean by that? What I mean is that the functionality that's being delivered is not core business transaction functionality. It's completely logic that has to do with exposing our business in creating the particular user interface that we need to achieve through the mobile UI. A UI level API, by the way, could be built to serve multiple different UI channels, or it could be built to serve a specific channel depending upon the requirements. By the way, there's a side theme if you want to look at it here in terms of a big shift that Netflix did to what it calls experience level APIs. So what Netflix does now is creates APIs that are intended to render and provide UI level elements. And we'll get back to this, to the distinction of UI level APIs a little bit. But an example here might be that, well, actually, let me build out one more bit, and then I can provide a better example. But the logic here is all about how it's presented. In the old three-tier presentation business logic data, sort of taxonomy. We're talking presentation logic here, some of which will reside on the UI, but some of which might reside in an API layer. Maybe that UI level API, is an interface then into UI logic. Maybe that UI logic is retrieving data from the back end. So another example here is where actually, I'll use a travel industry example where one of the travel reservations providers recently changed their APIs to where you can retrieve a list of available hotels, but you get very little information about each hotel. That allows the API user, in this case a mobile app or what have you, to sort that list however they want. Well, the core business solutions don't care how you sort the list of hotels. It just wants to tell you what hotels are out there that meet your criteria. It's a UI level thing, a presentation level thing to sort, cache, deliver 2 at a time or 40 at a time. These are UI level concerns that might be addressed by a UI level API. And so we get 2 different kinds of APIs here. Well, a useful way then to layer the implementation of these APIs is to have our core systems with the core transaction APIs and a layered implementation in the middle with a mobile back end, in this case doing the UI level APIs and the UI logic. So we provide a different layer of the architecture. Some of that UI logic, again, could be on the device. What we're saying is there is some logic here that's too big to support on the device, or that there are caching or other benefits if it's managed via a mobile backend. So we have here 3 different kinds of APIs and a layering of the architecture to help use these effectively. Now, there's some other things that we might do with the mobile back end here. One is, we've mentioned that mobile environments tend to want to have REST APIs. Well, if our existing business building block API has been there for a while, because our previous and currently still useful SOA strategy has a SOAP API. By the way, here's another point of religion. There should be no association in your mind between SOA and SOAP or between APIs and REST. APIs can be SOAP or REST. SOA can be done with REST or SOAP. But anyhow, maybe you have a SOAP API and you want to make an API facade to make it into a REST API. Or maybe at either one of the levels, there's some local data or cache data that is appropriate to have either on the device or in the API. So important distinctions and layering opportunities. And by the way, a back-end environment, let's drop the word mobile for a moment, a back-end environment might be a place where you actually create some of your business building block APIs as well. You still want to manage them as a core enterprise asset differently than these presentation layer APIs, but it's still a possibility there. Okay, so what we're talking about when we enter these kind of questions into the mix is an API design strategy. What we're saying is, don't just let your developers get out there and just say, hey, yay, let's go to town. Here's an API. Let's toss this out there. Let's put some structure as an organization around how we create APIs. Now, many Agile players, Agile proponents out there will, as soon as I say put some structure around it, they'll go, Agile doesn't want architecture and structure. We just need that. Well, that's another conversation, another bit of religion. Architecture and Agile can go together very well if you do it right. But At Forrester, we characterize 5 major areas of API design strategy. First, the broad categories of business context that drive different categories of APIs. Different API types, we just saw 3. I'll show some more on another slide here in a minute. Different interface technical design strategies for the messaging style, SOAP or REST, different kinds of payloads, XML or JSON, and others, security, quality of service. We'll do a couple of examples of that. But I won't talk more about community concerns, but what I want to say here is, for example, if you set limits on your API, that may impact how you design your APIs to ensure that people understand when and how they are running into those limits. Just have a look at Google Maps map load limitations and make sure, look at how you have to understand when you're doing a map load versus changing a map that's already loaded. And then there's concerns about future preparation. Open-ended design is where you just say, let's create APIs that anybody can do anything with, and maybe you want to do that. Maybe you're not that quite open in your business scenario and approach. Portfolio management is about understanding how your set of APIs will evolve over time. API strategy. Now, you commonly will hear of open web APIs or B2B APIs. As two major categories of APIs. You might also hear these called public and partner APIs. Think of these as a continuum, but the important distinction in terms of how it affects design is for open web APIs, you pretty much better be doing REST in the current API environment, unless you have a good reason and you know why you're doing something else. B2B APIs have may have much higher requirements for integrity, for data validation, for security and security federation. These can sometimes benefit from SOAP and WS security and additional built-in standardized functionality there. There's internal APIs, which are sometimes called private APIs. Won't talk about those anymore because I want to leave time to say a word about the 4th category that Forrester adds on, and I don't see this category talked about, product APIs. And this is about building an ecosystem around your product and about thinking and planning your APIs in a different way. Key example here, and then this is all I'll say about it because it's a whole other conversation, but is through a B2B API or an open web API, you might reserve a hotel room. But what about having an API into the hotel room itself for parental controls or what have you? That's a difference between a product API and a B2B API. Okay, different API types result in different kinds of functionality, or purpose and function drive different types is what I mean to say. And we talked about data APIs and transaction APIs. These are the primary 2 categories of business-oriented APIs. And again, the religion for REST would say everything should be a data API. But folks like E-Trade understand there's a good place for those, like for the E-Trade account API. But for submitting trades, it gets you to twist your head around to figure out, well, how do I want to do that in a data-oriented API? So a transaction API is an appropriate way to think about that. We talked about user interface APIs. Those might serve data for a UI or UI fragments or a fully formed UI component like the Twitter embedded timeline API. There is a place for technical integration APIs, but you've got to know that that's what your scenario needs. And there might be detailed application component APIs like face recognition API or a text processing API. Utility APIs would be, security, logging, other things like that. So different API types and and the guidance that you provide around them is a key part of an API design strategy. Couple of slides on detailed API design considerations, part of that technical design criteria within an API design strategy. I'd like to point out that REST is not so clear as you think, and again, the religion here would say, if you want to submit an order, it's a resource-oriented thing. But okay, so which is the correct handling of post-order according to the religion out there? Well, it gets to be pretty tricky. You could do any one of these. I present this question and to audiences when I'm live with folks, and it's kind of like, folks hesitate, and finally somebody will say, well, maybe C. Well, the answer really is whatever it says in the documentation, because there is no standard for how to do REST and even resource-oriented REST, which is okay. That does not say it's not beneficial. It's just to recognize the animal that you're dealing with. But there's a bigger issue when you get to some of these sorts of things, and let's stick with this order example. So, great, let's say the docs say, post-order, we'll submit the order for processing through the full fulfillment process and that sort of thing. Well, what happens if the API call doesn't get a response? Well, again, the answer is whatever it says in the documentation. So you need guidelines to make sure that you got bulletproof transaction management. Well, how are you going to do that? There's a couple of approaches. Here are the dominant ones that I see. One is a transaction submission protocol. What I first do is get a new order ID so that the API provider will expect a new order to be coming. Then when I post the order and I provide that order ID, then I can, as the API user, I can rely on the API provider to prevent duplicates. So if I don't get a response, I can just submit that as many times as I want with that new order ID in it, and know that so long as I'm submitting the exact same order and not changing it every time, then I know when I finally get a response back, that's when I know that the order was received and processed. Or you can have a lighter kind of thing where there's some duplicate transaction detection on the back end, where the protocol is, if you resend an order, resend an identical order, and we'll identify a duplicate and flag it and do some standard way of handling it. The problem is now you can't submit two identical orders within a given time frame, so that can be a problem. Depends on which to use here, depends on your business scenario. So, and these are just a quick little touch at many different design issues that you may have. So what I recommend here is don't just build APIs. Create a design strategy. APIs can open up a wide range of business opportunity, which then gets you that you need to understand what API types and how are you going to evolve a portfolio of business-oriented APIs. And that will lead you, as you understand the different kinds of APIs, to layer user experience APIs on top of business APIs, and then use a back end to integrate experience APIs with other needs. But use APIs for business effectiveness. That's the broader goal. Not just deliver mobile now, but deliver mobile now and prepare for future channels. Deliver business consistency and consistency of outcomes across different channels and different ways of using APIs. Because what you're trying to do with an API design strategy is build business agility. Ed, back to you.
Thank you, Randy. So I am going to jump in and follow up with Randy's discussion about the strategy and architecture of mobile APIs. And what I wanted to do was spend a few moments talking about some of the implementation issues for developers as you're tackling building mobile apps with APIs. And what we see from a developer perspective, people seek to address these challenges. And so one of the things that I think tends to be the most jarring disconnect and need to really reapproach the architecture is the fact that mobile development with APIs introduces multiple tiers. I say 4-tier here. This could be depending on how you structure your platform, it could be a 5 or 6-tier architecture, in fact. But one thing that's clear is that there are now multiple teams involved in the process. And this is something that is where the API need starts and where a lot of the consternation in the development process begins, which is that you now have, at a minimum, a front-end team building your mobile apps and a back-end team. And so APIs end up having to be defined between that front-end and back-end. Viewing the web as a client is a new thing for a lot of developers. And one of the things that I often talk about is how app servers have really set back architecture on a lot of fronts because the monolithic nature of the Java Application Server has hidden a lot of spaghetti architecture. The isolation of components and so on can happen in a willy-nilly fashion. And when you have to start breaking things out into services, you actually end up discovering those. Logic on the device. New stacks. One of the things that we're seeing now is an extremely heterogeneous and polyglot environment for building your apps and building your architectures. And a lot of this has contributed to the emergence of new layers of the stack. The back-end as a service that became popular in internet development for mobile applications and now is becoming a fixture in the enterprise architecture as well, come about because of these challenges, because of the fact that you now have multiple teams with multiple needs to tie these things together. From a perspective of what does your architecture look like at a minimum, you are in fact looking at a situation where you've got application code talking to some form of SDK, whether it's system supplied or whether it's vendor supplied, that is communicating, wrapping your API traffic on the network. There is an API tier that someone has built, perhaps developed by your application developers, deployed to an application server stack. Perhaps this is built and managed through an API platform, then your server infrastructure, and behind that, all of your back-end services. So your mobile client developers have a lot of considerations. They're dealing with the fact that they have to decide, should they be writing directly to an API? Should they be using an SDK? This has implications on their mobile environments. These conversations about SOAP versus REST actually have profound implications for the client developer. And in fact, one of the things that is probably the biggest sea change that mobile has brought and why it has catalyzed the requirements for a completely different perspective, architectural perspective, is because you cannot succeed with an effective mobile API strategy if you treat mobile as yet another client endpoint on your SOA architecture. And that is because you tend to go and look at, if you do service design in the right way, you take an arm's length approach to what the client is doing. In fact, your goal is abstraction as much as possible and reuse as much as possible at the expense of having any level of concern for any specific client. However, the realities of mobile and the network that connects your mobile devices to your back end makes that an untenable approach. You suddenly have to start thinking about, okay, what is this client? What are the languages on the client? What are the mechanisms that they're going to interface with these APIs? How can I actually make sure that there are fewer, more rich API invocations? How can I deal with things like invocation failure in a more graceful way? A lot of these are mobile client considerations. We also start to see interesting new challenges in security at the mobile tier that are often afterthoughts from a classic service design standpoint, but actually become life or death issues when thinking about mobile APIs. Identity. What are the mechanisms for validating the identity? If you're creating consumer applications, often Facebook is one source of identity. You've got various OAuth-related mechanisms for creating consent. The fact that you're dealing with untrusted devices. Oftentimes, and we hear this so many times, how do I encrypt my API keys within my application, which is fundamentally the wrong question, because no amount of encryption is going to protect the fact that your device is far outside of any security perimeter that you can reasonably hope to establish and hold. People will be able to grab that application and extract the keys no matter what you do. So that cannot be the basis of the protection of credentials. So you then have to look at situations like token vending or various forms of policies and permissions. The fact that these are untrusted networks, not just untrusted devices. There's been a lot of interesting examples of using man-in-the-middle mechanisms for reverse engineering what's being sent by application data, and a lot of security breaches that have come from that. So again, these are considerations and things that will prompt you to have to think about your API architectures in different ways. And then finally, how do you address the asynchronous model from both an engagement standpoint and also connectivity standpoint? And we see various mechanisms for that. We see notifications, the proactive delivery of content, of information, and of application actions from server side to the client. How do you implement that from an API standpoint in a network connectivity that has high reliability? Things like WebSocket are often the preferred mechanism. In the mobile environment, that tends to be a power draining mechanism, but other mechanisms such as polling have issues as well. Further, you've got the mobile operating systems all implement some form of push notifications. What's the interaction between API invocations and push notifications, which many times are sideband to the API channel? Those are things that often introduce a lot of considerations. The network availability problem, which will never go away, it has to do with the laws of physics, means that you have to think about your API usage in an intermittent connection scenario. You also have to think about offline. This introduces some interesting things related to API invocations that may be batch-oriented. You start to see things like client-side queuing of messages. You also start to see various types of queuing architectures. A lot of mobile developers use things like Amazon's SQS to try to deal with these mechanisms for connectivity as well. So these are some of the practical considerations that you often need to think about in your mobile architecture. And then the mobile debugging, which is a little bit outside of scope, but not entirely from mobile API and mobile application considerations. A lot of things that happen in debugging mobile APIs. You often see that timeouts can occur. API invocations that don't complete quickly can be timed out for a number of reasons related to network operators, related to issues in terms of cloud deployment, things happening at load balancers, things happening on the device. So a lot of things can go wrong in a lot of different places that can affect the successful completion of API-based transactions. Things like headers disappearing. These are things that we've seen in the field, in practice, people trying to figure out why their API invocations aren't working. They find that something related to their mobile development tool is dropping a OAuth header, and suddenly API calls are failing in certain circumstances. This last point of logging everything and having some form of mobile debugging within your solution becomes essential. These are things where what looks like a simple, on the whiteboard, looks like a simple mobile architecture. Here's my client. It's going to use this REST SDK. It's going to make these API invocations. They're going to talk to my server. We're doing everything right. It all looks good. Suddenly you lose days, weeks, possibly months of effort lost to debugging, troubleshooting of your mobile applications. These are the things that terrify people from a connected device, mobile API-driven project. And so we see a lot of these issues, and it made sense to call these out to you for things you need to think about. Summing up some of these issues related to your mobile development with APIs, keep in mind that most of your key application features, your interaction-related features that the user sees, in many cases, user interactions will directly trigger API calls, different user experience patterns, design patterns, interaction patterns, whether it is scrolling, whether it is how you complete a order transaction. All of these involve APIs that have to be designed to support the interaction. They have to deliver the right amount of data in a lowest latency way, so they can't over-deliver the data. You can't deliver a giant XML payload on something that has to complete during a user swipe interaction on a screen. These features are all cloud connected. There's often a one-to-one mapping between a user interaction and an API call. This will break some of your approaches to service design. You will start to build these, Randy had referred to as UX-based APIs. So have to keep that in mind. You will have new architectures. This is the revenge of client server. You'll have to think about your application spans for the purposes of your user and for the purposes of your business stakeholders. The application and the back end are not cleanly delineated. It's all one user experience. For you as developers and architects, it may be. So you have to think about this and architectures that support this. And this introduces lots of new development into the ecosystem. Again, the nice thing about application servers is that in many cases, everybody from the front end, JSP, Java Server Pages developer, down to the guy who was building the network-based resources, the distributed computing architecture, were all speaking Java. It was extremely homogeneous in how it worked, and in many cases you had developers freely moving from one to another. In the mobile world, we now have lots of variety. We've got lots of different languages. You've got your iOS developer scratching his head trying to figure out how he builds a REST invocation or an XML SOAP invocation when there is no built-in libraries in the iOS SDKs as supplied by Apple. For doing those, he's using third-party SDKs. And he is doing all this talking to the back-end services that are built that perhaps are being done by a developer who has had no mobile experience, and using services that previously had been designed to be principally invoked on the company's internal network inside its security perimeter, where you could be reasonably confident that service invocations would happen within a many nines of reliability versus the fact that once you start adding mobile networks to the equation, you could have 1 in 3 requests failing for your application. So those are some of the considerations that we toss into the mix when thinking about mobile within an API architecture. Some of the things that this translates into are summarized on this slide. The mobile API value chain, this is something that we like to reinforce when we're talking to people about thinking about this. What's the perspective of the developer, the application developer, who is constructing application experiences that are directly touching the user, and how does he or she interact with the API team that is looking at taking your core digital assets, the services that are built, managed, exposed within your service-oriented architecture, with APIs being the mechanisms for combining them. That tees up a whole set of concerns that are necessary to support this value chain. Things like self-service developer portals, things like mobile backend as a service that will vastly accelerate the productivity of these application developers, giving them faster time to market. How can your API team meet these needs in an agile fashion while also meeting the IT needs, that the cost of which will be driven up if you're not careful as you have new security needs while trying to meet the requirements for a business to be more responsive to the application developers who are often in the front lines of meeting these business requirements. We like to talk about some of the examples of people who have implemented these types of architectures. We're short on time. I'm going to do a quick call out, shout out to Walgreens. It's been a great example of building mobile applications where you needed to go and meet the needs to deliver customer-facing application in a very short amount of time, where you were combining sets of services. In this case, the order processing services that had to do with digital photography fulfillment, as well as your prescription services. Those needed to be surfaced and exposed in a way that they could be agile, used in an agile way by application developers first externally to the company in the form of digital agencies and application development partners. And then those self-same APIs needed to be exposed in a way that could satisfy B2B scenarios where various healthcare providers needed to be able to deliver prescription orders directly into Walgreens fulfillment services, as well as being able to open this up to third-party developers as more and more application developers in the iOS ecosystem wanted to be able to take their photo printing apps and print those directly to Walgreens quick print services. This was a good example where you had a company needing to first bring their first-party apps to market in a very agile way, and then opening that up to B2B partners as well as select developer application partners to really become a permanent fixture in the mobile ecosystem for one of the hotter categories in mobile, which is photos, photo editing, photo taking. We see this as having been a great success story where being able to build a mobile architecture, mobile APIs, and recognizing the reality of the needs of mobile development, which is still very messy, to create stable, successful mobile apps. Last couple of slides, I'm actually going to skip past these. These will be topics for another conversation, but being able to do things like mobile personalized offers and customer service optimization, these are some of the types of things that a mobile API strategy will let you address. As I said, I think these are things we're gonna save for another webinar because we've had such great information, content from Randy. Still have plenty of stuff we can cover in future webinars. So with that in mind, I want to thank Randy again for joining me on this webinar, and I want to see if we can answer a few questions. I'm told we've got time for a couple of them anyway, and we have a few in the queue. I'm going to take a look at the question answer queue. I've seen a lot of backend as a service pointing to NoSQL databases. Do we have any constraints about mapping backend as a service to a relational database management service? So this is a really good question. Actually, this is one that I get asked a lot, given my involvement in developing backend as a service, user grid, and so on, and Apogee's backend as a service capabilities that are part of Apogee Edge. So why do you see NoSQL so closely aligned with backend as a service? The answer is that typically the backend as a service is addressing the needs of the application developer, the parts that have not been addressed through existing APIs built off of existing services. So as a consequence, they tend to address the areas where there's sort of a high degree of flux in the requirements and where going to a strongly defined schema for your data tends to challenge application developers. So it doesn't mean that you couldn't have a backend as a service with a strongly defined schema, but typically, once you do have that strongly defined schema, you actually tend to perhaps move off of a backend as a service, and you're actually moving to more of a perhaps database as a service, where you aren't going to have the need to make as many changes to your database because your application design has been more fixed in scope. This is not a hard and fast thing. This is definitely a gray area type of requirement, but it is the reason, again, why you've seen this. It's not just an architectural preference on the part of people who build backend as a service. What they've tried to do is listen to what the application developers are saying, which is that our apps are having high rates of change. We're adding features. We are doing updates where now we want to collect this piece of information, and we don't want to be doing sort of a alter table all the time to add new columns to our tables and so on. So that's kind of why you see that.
And I just add on add on that there may be just some specific technical scenarios like session management or session state or something that just may operate more effectively there, or you may have other things where you want to distribute session state in a geographic replication, for reliability or what have you, and there are some ways in which a Cassandra ring or whatever might address those in a more effective way. So there's some other technical reasons, but in the end, you use the data store that's right for the scenario.
100% agree with that. I think that's a lot of these things. A lot of these things tend to, at least for the exactly. Actually, I would say that some of these things end up being historical from a NoSQL standpoint, that they did support geographical replication much better. You're now seeing that some of the relational databases are catching up on that, although there are still some challenges. again, this is one that might be a great topic for another webinar as well, because actually it's one of my favorite topics. Do you see partner management capability APIs interfacing with technical APIs to control what we expose depending on the partner relationship, public versus B2B, internal versus external? Let me take a stab at answering what I think I'm understanding that question to be about, and Randy, you can take a shot too. I think one aspect of this is, do people oftentimes see the need to create different types of partner APIs depending on or based on some of the requirements of the partner relationship that require you to create perhaps a different set of APIs? The answer to that is yes. We do tend to see that partner APIs often mandate a different type of structure than a mobile API, for example. And so that's something where, for example, an API management platform might give you the ability to manage a disparate set of APIs based on different requirements. That's kind of how I would interpret this question. Randy,
I think there's another angle. I think there's another angle embedded in this, which is the whole partner management issue within the B2B category of APIs versus open web APIs, and that leads to a number of different things. But visibility of APIs is a key concern. Security and functionality of what happens at runtime, from an API enforcement based on what partners are authorized for, and there are a number of different kinds of things, whether those are actual APIs or a function of the infrastructure or the like. There could be differing particular designs about it, and I don't see anything particularly necessary in the angle in the question on interfacing with technical APIs. Still, if it's something that a partner is calling, I'm going to be pretty hard-pressed to say, let's do technical APIs to our partners. It ought to still be a business API, but there may be internal technical APIs that we have to call and integrate to implement a partner management capability. But there's a whole set of design issues and API exposing and architecture issues that tie back to partner management in a B2B sense.
Okay, we got a couple of more questions that just came in. I am developing a conference mobile app, researching as to whether I should use a mobile backend service or build APIs using a framework with Mongo as a database. Can you help me choose which backend to choose? So this is actually, I think, one of the biggest questions that I see from mobile developers related to APIs. Certainly, I think that the big three options that you tend to see are: should you use a mobile backend as a service? Should I use a framework with Mongo, or should I use existing services and make them mobile ready through some form of transformation, perhaps using API management? So if you're using a mobile backend as a service, I think that the question you have to ask yourself is, how well do your application requirements map to what the mobile backend as a service provides? Mobile backend as a service is designed to be an accelerator for your development. It does this by presupposing that your application is going to be built on a set of the most common application design patterns. And assuming that it is, then your mobile backend will save you quite a bit of time. If what you find is that your APIs are going to be very specific to your application, and that you're not benefiting at all from the reuse of back-end APIs provided by a back-end as a service, then you start to go and say, okay, I'm going to have to develop these myself, and in which case that's where you tend to see that people use something like Node.js, and then the question becomes, where does your data sit? And perhaps you'd use something like Mongo. I guess what I would do is I would recommend first taking a look at the APIs of a mobile backend as a service as a starting point. Why should you do this? Because most of the major backends as a service have very well-designed APIs that take into consideration a lot of the challenges you will face from mobile API invocation. And so these might make you think a little bit more about what some of these challenges, mobile challenges, will be before you go and design them yourself. So that even if you sit down and say, okay, I'm going to just grab a framework and I'm going to do this for myself, at least you'll come to the table with a better perspective of what some of the issues are involved. Then I think the second question around that just is really, how much time do you have on these apps? The people who benefit from using a backend service tend to be ones who are building lots of apps and need to do so in a short amount of time. Tools for migrating from relational databases to backend service. So typically the process ends up being one around data denormalization. Most backend service, particularly ones that use NoSQL, you typically want to sort of unroll your data out of whatever highly relational form you might have it in, and move it into this type of service. This will actually be pretty much a similar process whether you're doing it to a backend as a service or whether you're doing this to a NoSQL data store. There are some tools available for doing this sort of thing. You often tend to also write your own scripts to do it.
I think we covered quite a bit, and there's always a lot more to talk about in terms of API design, best practices, and details. I mean, you've seen my 5-part series of reports on that topic, and I felt I was just scratching the surface with those. So maybe we'll leave that for another day.
Well, it sounds like if nothing else, we've teed up some potential follow-on material. I do also encourage people to go and take a look at Randy's writings on the subject. It's a great series of content, and this is a great topic. This is, I think, mobile is what has transformed the nature of APIs, unlike I think anything else. And so this certainly won't be the last word on it. And thank you all for attending.